Hello, I'm going to explain you how we will calculate increase and decrease intervals of functions. I've drawn here a generical function called f, chosen some random points, drawn tangent lines in them, and we will analyze the gradient of all these lines to the derivative at these points. Here, the lines are increasing, so the gradients of these lines are positive, and that means that the derivative f prime are positive, greater than 0. Here we've reached the maximum where the tangent line is horizontal, and that's why f prime is 0. Then the function is decreasing until we reach a minimum where again the function derivative is 0 because the tangent line is horizontal. Then it is increasing again, the derivative is positive, maximum again, derivative 0, decreasing, so f prime is negative, smaller than 0, decreasing until it stops a little bit over here, but there's not really a change because it continues decreasing again. But the tangent line here is horizontal, that's why I've colored in red. So it seems that if we were able to calculate all the points where the first derivative is 0 and analyze the signs of the derivative on the left side, right side, would be a good way to analyze if the function is increasing, decreasing, and so on. And this is exactly what we will do. I mean, we will always draw a real line, a line here, locate all the points where the first derivative is 0, and analyze the signs in these intervals, and the signs of the derivative. So here the derivative would be positive, and that's why I've drawn an arrow going up. Here the function is going up. The first derivative is negative, that's why the arrow is going down, up, down, and again down. And here we've got a maximum, here we've got a minimum, maximum, and well, we want to speak right now about this kind of points, but you realize there's not really a change. The function was decreasing and it continues decreasing again. So we've got maximum, minimum, maximum, and special point over here. Well, the most important conclusion for the moment is that if the first derivative is positive, f is increasing, the function is going up. If the first derivative is smaller than 0, negative, f is decreasing, the function is going down. Okay, and all the points where the first derivative is 0, so the tangent lines are horizontal, are called critical points or singular points. And there are a few kind of critical points, okay? There are maximums, where there's a change from increasing to decreasing. We've got minimums, where there's a change from decreasing to increasing. And these two, as you know, are extreme points or turning points. And then we've got the third kind of critical points, which are inflection points where the tangent line is horizontal. And there could be a stop while the function is decreasing and it continues decreasing, or there could be a stop while the function is increasing and again increasing. But okay, I've drawn the tangent lines, and as you see, they're horizontal. That's why at these points the derivative is also 0. Okay, so they're critical points even there's not a real change.